All right, everybody, SV Math Teach here. This time from some undisclosed location, I'm in a gym. So there's bad noise all around me, weights clanging, music, and stationary bikes. All right, so let's do this thing, right? It's Monday, and you guys are going to work on creating polynomials if I give you the roots. Now, the document you're in is a long one, right? It's the same doc we were in the other day. And here's what we've got, right? Let's imagine that I'm looking at this problem right here. If I tell you what the roots of something are, or the zeros of something, you should be able to work backwards and come up with the polynomial itself. So if I tell you that if 0 is one of the zeros, then you could simply write x. If I tell you that 3 is one of the zeros, then you would write x minus 3. This is kind of like synthetic division, right? It's the reverse of synthetic division. And likewise, if 2 plus or minus 3i is one of the roots, then you have actually two roots. You have the x minus, let's write that again, x minus 2 plus 3i, and you have x minus 2 minus 3i, because it's x minus whatever the root is, right? So we have those two things, and they're simply putting them together right here. So imagine that we took these four items, the x minus 3, the x minus 2 plus 3i, and the x minus 2 minus 3i. When we put them all together, when you remultiply all of that stuff, you're going to end up with, here's the remultiplication, right? So you can surely look at this on your page. You're going to end up with this polynomial, and that is the polynomial that has the roots that we described earlier. It's kind of neat to look at this guy here. There is probably a way to do this faster. The way I've got it going on here, I definitely have seen some patterns when you multiply this back together. But for now, we're going to go with the basics. It's also getting noisy in here, so let's dive right in. In the first one, I'm looking on page 330. It says find a polynomial function that has the following zeros. So minus 3 is plus 3. This sounds like, is this Ariana Grande? I don't know what it is. It sounds hideous, but we're going to keep going. So I got x plus 3, x minus 2, and x minus 1. So what we're going to do is try to solve these things. Remultiply them all together. So I'm just going to remultiply here. I'm going to get x squared, let's see, minus 2x plus 3x minus 6. And I'm going to clean that up to x squared plus x minus 6. And now I'm going to take that and multiply it by x minus 1. Now this video is going to get pretty lengthy if you watch me multiply the whole way through, but the idea is you multiply that down through, and you will have yourself your function, right? You can do that. You don't need to watch me do it. You've done it before, and you will do it again. So that's the concept. You just put them back together. Now there's very little going on here that isn't just like that. A couple of them that are a little sketchier are the ones where there's two parts inside of the root, and those are a little bit harder. I think I have an example lower that's going to help us out. So let's come down to here, and I have flagged two of them that I want to try. Now, I'm leaving most of A through I. By the way, the plans the substitute's going to say has A through L written. It should be A through I, so don't worry about that. Don't even worry about what might be on their subplans. It should be A through I, and your homework for today is to try to take care of A through I. Very simple, right? Classwork and homework put together. To help with a problem like E, where you have something with two parts, I want to show you a more complex version that has two parts down here. I also need to teach you something special. So I'm going to teach you something special first, and then show you how to finish it off last. What you see here are you have imaginary numbers. And a number of you would tell me that you can't have just one imaginary number, right? We can't have an odd number of imaginaries. So even though I see this first thing of negative I really have negative I, and I also have positive I. And here I have positive 2i, but I really also have the opposite of that. I have negative 2i. Every one of these is going to have a plus and a minus version. So this thing actually has 6 roots, not just 3. So even though they don't list them all, don't be distracted by that. So you're going to do x, let's see, if I look at this one, x plus I, and if I look at this one, it's x minus I. And this one would be x minus 2i, and this one would be x plus 2i, and x plus 3i, and x minus 3i. Now, this sounds like a disaster, but it really isn't going to be too bad. So we're going to put these things together in clusters. This is x squared. The minus ix and plus ix cancel out, so you just end up with minus I squared. And over here, you're going to get x squared minus 4i squared. And over here, you're going to get x squared minus 9i squared. And we know I squared equals -1, so this is really just x squared minus -1. This is x squared minus 4 -1s. And this is x squared minus 9 -1s. So let's clean that up and just do x squared plus 1, x squared plus 4, and x squared plus 9. Now again, this video is going to be super long if I show you how to work all that out, but really you just remultiply. I would just remultiply these two together, x to the 4th plus 5x squared plus 4, and then multiply by x squared plus 9. And again, I've seen you do problems this hard. I'm confident you can do them again. That's the concept. If I have something a little bit more interesting over here off to the side as our last example, I'm choosing letter E at the bottom there. So I have 1, 1, and then 2, 3. I have 3 roots here. So here we go. X plus 4, x minus 1 plus 2i. So I do the positive version. Now I'm going to do the minus version. X minus 1 minus 2i. Right? That's how I do it anyway. And because I know that there's probably going to be a lot of stuff canceling out here, I'm going to multiply these together first. What I'm going to do is this. I'm going to go ahead and multiply x minus 1 plus 2i. And I'm going to write x minus 1 minus 2i right underneath it. And then I'm going to multiply, kind of old school, just like if I were multiplying like 103 times 27, right? So you'd multiply like the 7 times 3, then 7 times 0, then 7 times 1, and then you would leave a placeholder, and then you would do 3 times 2, and 2 times 0, and 2 times 1. And then when you had all that stuff, you would add them together, and they would already be in their columns, and you would end up getting your answer. So using that same concept, let's go ahead and do this. This is the last piece of the video, by the way. So I'm going to go ahead and take my 2i and multiply it by these 3 parts. So here we go. So negative 4i squared plus 2i minus 2ix. All right. Now I'll leave a placeholder. And now I'm going to take my -1 times these 3 things. So here we go. -1 times 2i is negative 2i. And see how that lines up. And this one doesn't line up. Now when I do the middle term, this is going to kind of throw me off. I have -1 times -1, which is +1. I have nowhere to really put that. I'll be honest, I'm just going to put it kind of anywhere. I just don't want to forget about it. So I'm going to put it over here where constants usually go. And now I'm going to do -1 times x. And I don't really have a spot for that either. So if I don't have a spot for it, I don't know, let's see. Let's put it over here, -1x, right? Notice how I'm trying to leave kind of columns, if that makes any sense. I'm trying to put things in columns that are the same. So I've done the first 2 pieces. Now I'm going to add my placeholder again. Maybe I don't really need these empty boxes because they don't really seem to be doing what I'm after anyway, because I'm doing more like a combined like step term. So now I'm going to do x times 2i. So x times 2i is plus 2ix. There, that lines up nicely. X times -1 is -1x. All right, there we go. And x times x is x squared. I don't have an x squared term, so I'm going to go ahead and just put a x squared out here. All right, just like I would before, I'm going to add everything together. I've got a +1 out here. I've got, now look at this, -4 times what is ultimately -1, right? -4 times -1 is +4, so that's kind of nice. Those two are going to combine. I'm going to grab a red pen because I do get to cross a couple things out. Plus 2i and minus 2i cancel out, so we don't need to worry about that. Minus 2ix and plus 2ix, they cancel out. And I do find that this happens almost all the time, so those steps go away. Minus 1x and minus 1x makes minus 2x, and x squared comes down. So look what I end up with. I end up with x squared minus 2x plus 5, and that's what I get out of that big mess, right? So I started with this thing, which is really messy, and I end up with this thing, which is really not messy at all. You'll note that I still haven't dealt with the x plus 4, so now I'm going to go ahead and multiply by x plus 4. And once again, you would use whatever strategy you use to solve that from there. But that's the strategy, right? So rather a long video, but if we were in class, that would have taken 20 or 30 minutes. You've had a chance to see kind of what to do when you have two things. You've had a chance to see what happens whenever you don't have all the roots given to you, but you have to make sure you remember all of the roots. You've been entertained by, maybe this is Aretha now, I think. Some Christmas music, and yeah, all right. So good luck to everybody. Make sure you do a lot of remultiplying today. You should be allowed to lean across left and right, front and back, and talk to the people around you to get some answers. And email me if you have questions. Otherwise, I will see you on Tuesday.